Everyone's doing okay. I hope everyone is safe and sound, and we're going to get through this. And I'm going to make some coffee while we talk. So one of the things that, just to pass some time before we get going, one of the things that, so I grew up kind of poor. Like my father had fame, but he didn't have fortune. And so that meant sometimes you were a little bit hungry and maybe didn't have nice clothes. And there were times where we didn't have heat or electricity, and a lot of struggles growing up. And, my wife kind of was the opposite. And she came from a home where, dad had a middle-class job, and, they had a nice house, and, everything she needed, she had. She never had to worry about, like, okay, is there food on the table? And then, my parents are still kind of not as productive as they could be, let's say. And she always says, I don't understand. How can you come from that environment and do all the things that you do and care about the things that you care about? And I'm like, I don't know. You just do what you do. But I've been thinking about that a little bit, and I wanted to share that with you guys. And I think that the secret is that you always bet on yourself, right? You're the best bet you got, and don't ever believe that. I know that people talk about imposter syndrome and things of that sort, where you feel like maybe you don't belong, or maybe you're not as good as you should be. And I think you should try to get those thoughts out of your head. You should always bet on yourself. And I think that's one of the keys to overcoming difficulties in the long run, because there are going to be difficulties. You can't escape it. Life sometimes, just like now, we're in the middle of a pandemic. But always believe in yourself and always bet on yourself, and you'll be, that'll go a long way. All right, so I'm going to get started. It's weird giving these talks because what you do is you see a bunch of little blank screens, and so it looks like you're talking into the abyss. And that's why everybody comes on and says, hey, can you hear me? Can you see me? Because you really don't know, and you don't get that visual feedback. This is a lecture that I've given multiple times now. I tried to mature it a little bit, and we're actually going to expand things this year. We're going to add some more lectures. So I'll come back and go in a little bit more details about some of the things I'm going to present today. Please, we'll have plenty of time for questions, and I'll try to have the little chat thing open. So if you have a question, you can use the chat. It'll be off to my right.
Hey, Romain.
Yeah.
One quick thought. Ashley, I don't know if you have any just brief sort of intro. You sent out that email because Romain briefly introduced the fact that this is, going to be the first of several different lectures. Do you have any? I'm going to be giving the next talk on July 31st, so I'll be able to orient people a little bit more to some of the research content that we're still firming up a little bit. But do you have any thoughts or anything to say about kind of this curriculum, Ashley?
Sure. We are hoping for this to be a space and some time to kind of fill in the gaps in your curriculum for things that we think are going to be helpful for your lifelong career in medicine, and maybe don't fit into the traditional otolaryngology curriculum, meaning we're thinking of topics that are more outside the box. So things like research, and we actually had a really nice business of medicine talk today. That's the kind of content that we're thinking of, that we're considering for this time slot. In the next couple of months, we're going to have someone from the Office of Diversity talk to us. Things like maybe having panel discussions for people in different types of specialties. So it's the curriculum will repeat every 2 years. And if you have any thoughts on what you might want to hear, I'm definitely open. Nothing is in concrete or anything at this point. So let me know if there's any burning topics that you would like to see in the next couple of years. But I think it's going to be really good. I look forward to your feedback.
All right.
Thanks,
Thank you.
Romain.
Thank you, Dr. Day. Thank you, Dr. Aiken. Your picture's over here, so when I look this way, I'm looking at you.
I know.
But the camera's there.
Yeah.
All right. So, maybe we should record the meeting, whoever has that capability, just in case, put it for our archives. We can always use it to, we could put on our new Twitter page or YouTube or something like that.
It looks like it's recording.
I am
Right.
recording.
Red dot at the top.
Okay, perfect. Thank you. All right, so I'm going to give you an overview on how to get your research projects going. I mean, that's essentially what this talk is about. And again, it was because what contributions do we want you, the residents, to make to otolaryngology in general? One of the contributions that needs to be made is we need to advance the science. We need to figure out what doesn't work and what does work, what we don't know, and improve upon it. That's one of the most important contributions that we all can make in this field outside of just taking care of patients individually. And we didn't necessarily have a good structure for that maybe 5-10 years ago. So I started giving this talk just to provide an overview of a way to get your projects going and make them tighter and hopefully increase the contributions as well as the results that you'll get from doing your research. I don't have any conflicts of interest and no disclosures. All right, so let's talk about our aims and objectives. So we're going to just go through some basic concepts. How do you generate a hypothesis? What's a power analysis? Chart review, data collection, basic statistics, and then sort of presenting data at conferences and getting things published. Again, we're going to go into much more details with these topics in the future. So this is just going to be an overview to kind of get the ball rolling. Hopefully you'll become more familiar with things like how do you do a hypothesis-driven project as opposed to a fishing expedition? Why is a power analysis important? How to help you get, do a better job in the long run. And then moving your data towards REDCap, maybe getting away from Excel spreadsheets and using more REDCap online data storage. How to think about recording your data, the difference between continuous and categorical. It makes a big difference in terms of how you're going to analyze the data in the long run. We'll go through some basic statistics. What are hypothesis tests? How do you choose which one? And then the STROBE statement, as well as other checklists for publishing data, and then sort of like structured abstracts, introductions, discussions, things like that. So again, what's the best place to begin? It's with an hypothesis. And that's always going to be the key to every paper you write. If you have a stronger hypothesis, the paper will be better and it's more likely to get published or presented. And so you bear the fruits of your labor if you have a strong hypothesis. So a fishing expedition is a little bit different. That's where you just say, okay, you don't necessarily know what you're looking for. You just want to see what's out there. You're doing an exploration, if you will. And the problem with that is because you don't really know what you're looking for, you may not find it. So if you say things like, well, let's just look at our fungal sinusitis patients, or let's just look at our laryngectomy patients, or just, how many tonsil bleeds do we have? Or let's just write a paper on trach patients. If that's your basic approach, it's going to be difficult to bring the paper home because you don't have a good working plan. So you're kind of just in the wind, so to speak. So again, most likely you're not going to find anything because you weren't really looking for anything. And you've wasted your most valuable time with your possession, which is your time. The clock, and I like to say this, the clock don't stop. I've been here now almost 15 years, probably longer than that. And it's hard to believe, right? And I'm sure those of you who are fifth-year residents, you can remember, like, it just seemed like yesterday that you were an intern. And next thing you know, I was talking to Alex recently, and I remember when he was a third-year medical student. In fact, he may have been a second-year medical student that we were working on a paper, and now he's a fourth-year medical student. And so Yeah, the clock don't stop. Now, there are sometimes studies that seem like a fishing expedition, but you can still tweak it and make it a paper. So it is good to know how many patients have laryngeal cancer, because that's part of the epidemiology of the disease. And it is useful to describe the pediatric population of OSA, because again, that helps us identify children at risk. But when you do those kind of studies, that knowledge is needed. There's no data on it. You shouldn't just do it because, oh, it's easy to do. So an hypothesis, on the other hand, is, you have a supposition, you think, you have this belief, and you have a proposed explanation, and you have some evidence for it, and you're using that as a starting point to go further. You're trying to advance knowledge as opposed to just reaching out and just seeing what's out there. So these are some examples of hypotheses that could work in a paper. So obese children have higher rates of severe obstructive sleep apnea compared to normal weight children. Children with OSA have more respiratory complications after tonsillectomy. We think we can treat tracheal stenosis with bioabsorbable stents. We believe that the number of salvage laryngectomies have increased over the last 5 years at our institution. And we believe tympanostomy tube insertion should take seasonality into account. Those are all hypotheses that you can test. You kind of know exactly what you're looking for. So again, it helps maximize your most valuable time. It helps maximize your time, which is your most valuable resource. And it focuses your efforts. You know which patients you're going to look for. So we want obese patients with severe sleep apnea who had a tonsillectomy. We know exactly which patients we need to look at, as opposed to, well, let's just look at all tonsillectomy patients and see what's out there. One quick warning before you start any research paper, just do a quick literature review, because one, it'll help you drive your hypothesis and make sure you're on the right track. And two, if somebody's already done the paper, you have to tweak it a little bit in order to address the knowledge gaps in that paper if you're going to try to get your paper over the hump. If you essentially write the same paper that somebody else wrote, you can still get it published, but it's a little bit harder. So I think this is just a good example of an introduction. The hypothesis is kind of implied, but it's just a good way to approach a research topic. And so this is from the CHAT study. Dr. Mitchell is one of the authors. And essentially they said, okay, what's the problem? Childhood sleep apnea, there's a lot of adverse effects, and it affects behavior and cognition. And then they said, well, we got some proof for it. It's most likely due to kids with big tonsils, and that's why so many tonsillectomies are done. But there's a knowledge gap. We really don't know if it works. So we know kids have sleep apnea. We know that the most common risk factor for sleep apnea is big tonsils, and that's why we do a lot of TNAs, but we really don't know if TNA actually helps the sleep apnea, particularly the cognitive and behavioral deficits that are found. And then they said, okay, this is how we're going to study the problem. We're going to do a randomized control trial. And then they kind of implied the hypothesis that maybe there should be some differences in outcomes. I always go back to the CHAT study when I'm sort of thinking about research design, like, okay, what did they do? Okay, they defined a problem. They provided evidence for the problem. They said there was a knowledge gap, and they showed how they were going to study that knowledge gap. And then you can add your hypothesis at the end. All right, so so you've done all that, you got a good study hypothesis, it hasn't been done. So now you got to maximize your time. How many charts are you going to review? Because sometimes you just go and people say, well, let's review 2,000 charts. Well, that wastes time. You may not need to review that many charts. Or if you don't have enough patients, that's the same thing. You're going to get hit back on the other end. There are not enough patients in your study. We're going to reject it. So a power and sample size analysis is essential because it helps you figure out how much time you need to spend reviewing charts and making sure you have enough patients in your study to test your hypothesis, so you're likely to get a good study result and analysis. So again, power analysis helps you from doing too much or too little. So let's try this. This is an example of a power analysis. So we said, okay, kids with severe OSA have more respiratory complications after tonsillectomy. So we did a literature search. Yeah, other people have done it, but there's some limitations. small sample size. Maybe they didn't look at young kids. Maybe they didn't have sleep studies for all the patients. Okay, so we think we can do a better job of answering this question. So now we need to know how many charts are we going to review. So you look at your historical data, see if you can find out, well, what's the average number of respiratory events after a tonsillectomy? And then you do things like, okay, let's calculate the p-value that's needed. Most studies will use 0.05. Some studies will go with higher p-values, but most go with 0.05. Then the beta is the power, 80 is the standard. Effect size just means what's the difference in outcomes, or strength of association. So most people look at difference in outcomes as the main point. So if you say the percentage of patients with severe OSA who get respiratory complications should be double the number who don't get it, if they don't have severe sleep apnea, that's kind of the effect size. And then you can do R squared as well. It's funny, there's a little typo here. And there's a joke that says, what's the best way to find a typo? Submit it for publication. Anyway, all right, other studies, parameters, do you need to control for age or gender? All right, so most observational studies are going to look at means or proportions, but it does require some strategic thinking. What's a reasonable effect size? Is 5% reasonable, 10%? Obviously, if you pick 50% difference, you don't need that many patients, but is that a reasonable effect size? And then what parameters are you really looking at? So are you looking at all respiratory events or just the events that require admission or ICU stays? So if a kid desats in the PACU, is that really what you're interested in? Or do you want to see kids that get admitted to the ICU because of continued oxygen needs? And then what happens if we change our focus? And that, that's kind of sensitivity analysis. If we want to look at kids with Down syndromes, or we want to look at kids who didn't have a sleep study, how much do we need to change our data analysis, our power analysis? So in 2019, we did about 2,500 tonsillectomies. About 450 patients had proven severe sleep apnea. And then according to the CHAT study, respiratory events were about 7% of that population. So if we do a power analysis, 0.05, 0.8 is alpha is 0.05, and then power is 0.8. And then this is the effect size, the delta. And so we're saying, okay, 7% is the standard rate. And then, okay, what if those with severe sleep apnea, it's 10%? Well, then we need about 1,300 patients in each group. Well, what if we say it's 15%, roughly double? Okay, now we need about 240 patients in each group. And then if we say it's about 2.5, then we need fewer patients. So obviously the bigger the difference, the fewer patients you need. This is probably a reasonable number here, because we don't have 1,300 patients with severe sleep apnea, but we do have 400 patients with severe sleep apnea. So we should be able to find the difference if it's there. All right. So you've now done your power analysis. You know how many charts you need to review. Now you're going to start doing chart reviews. I recommend everyone use REDCap. Now, I think the residents, I don't think you guys can start your own REDCap database. An attending has to do it. But most of your studies should be with an attending. So I think you should try to talk the attending into using REDCap. Not everybody uses it. Some people still like Excel, and it's okay. But I think REDCap is better just because it's secure, it's online, everyone has access to it. So even if you're at Parkland or at the VA, you can log into REDCap and enter data. Where if you're using like Excel spreadsheet, if you put it on OneDrive, sometimes it's hard to access at Parkland or from home. You got to log into the VPN and all this other stuff. And so REDCap's a little bit easier. The other thing about REDCap is you can download the data in any format you want. So it's fast, it's easy. You can export the data to any format you want. I use Stata. But a lot of people use SPSS or R, and you can even download it to Excel. You can even do PDF files. And then you can get some reporting just within the program, even though I don't use this very often. I use more of the Stata, but sometimes I'll look at the reporting just for things like missing values. The files can be sent secure. You can de-identify the file. So you can put all the medical record number and name and date of birth and address. But when you want to send it to your statistician, you can take all that data out and then send them the raw data, and it's more secure. You don't have to worry about HIPAA compliance. You still need an IRB approved for any research data collected, but for those of you, you know, we've kind of skirted that issue on some studies. All right, so let's see if, I'm going to skip that because every time I click on it, sometimes it doesn't work when we're in the PowerPoint. But I think for now, most of you have seen REDCap. Let me know if you want me to give you a more detailed presentation. Maybe that's one of the things we'll add to it. But it's really helpful. So once you sort of start entering your data, even if it's with Excel, you got to know how to code your data for back-end analysis. And so if you don't code the data correctly, the person who's analyzing the data is going to spend a lot of time just trying to recode your data to make it work. And so, and then again, that wastes time, and that's our most valuable asset.
Romain,
yeah.
Can I jump in and add to that?
Mm-hmm.
Courtney, who I think has done projects with you as well, is doing a project with me. And I see Courtney's on this call. Courtney had to code for we had data entered in a way in which the same variable was entered in 12 different variables and had to recode every variable as such. So just to emphasize exactly what Romain said, it's really like the work that you put at the beginning of the project pays huge dividends later. Courtney, do you have anything to add to that?
Hi. I guess just besides the thing is, like, you know, you said like it took forever to add every single code in. And then we had to, you know, use a bigger form of data, and it just became like a whole process and added a lot more hours. And then I think like other decisions that were made, like branching logic, which we talked a lot about, is like sometimes it might just be easier and like keeping things more simple if you don't fully understand how to use REDCap, because then down the road it could make things a lot more difficult.
Yeah. Yeah, so we paid it, specifically Courtney paid by having to spend a lot of time recoding stuff. So anyways, Romain, I hope you don't mind us interrupting, but it was to emphasize your point.
No, I appreciate it. That lets me know there are people out there in the universe. Hi, Courtney. You actually entered data for me too in REDCap. And again, sometimes you have to look at, as you start to enter the data, you realize like, okay, we haven't formatted it correctly. So the other thing that I do is I have you enter like 10 charts to start, maybe 15, and then stop, and then we re-meet, and then we talk about, okay, is this data working? Because we don't want to try to enter 100 charts, and then we're like, we forgot that this isn't quite correct. So that's the other thing that I think is nice about REDCap, is that, you know, you can modify your survey very easily too. The best numbers to analyze statistically are going to be 0 and 1. You know, yes, no. So the more data that you can have at 0, 1, the better. So gender, you can do that. Some people do 1, 2 for gender, but I usually do 0, 1. Yes, no categories, again, 0, 1, 0, 1, 0, 1. For multiple categories, I usually will use whole numbers, and I won't necessarily start with 0 unless like 0 is none or something like that. But typically, if there's no none feature, like a Cotton-Meyer classification, use whole numbers. And then, you know, don't ever use words, but that would only apply to like Excel. Just don't ever use words, because you can't analyze words statistically. They have to be a number, and it's prone to typos. And so what'll happen is you'll have 500 charts or 500 observations, and you're like, well, the numbers don't add up. Like, oh yeah, Hispanic was spelled wrong 5 times. Okay, let me find those charts. And you just spend more time wasting if you code your data as a name as opposed to a number. And so you just make sure you have a code book. So, but Stata does it for you automatically, so you don't have to do that. But if you use Excel, have a code book. Usually you put it on a separate tab. Try not to have, so your spreadsheet, if you're using Excel, your spreadsheet that has the raw data on it, only have the raw data on the spreadsheet. If you're going to do a code book, have it on a separate tab. Because again, when you download that, or you import that data into a statistical software, that those extra spaces at the bottom that has all the code in it, the software thinks that's an observation. So then you have to figure out, like, well, how come I have 500 observation, but there's only 450 patients? What's going on? Oh, all this stuff at the bottom, I got to delete it. Oh, is it important? Always have it at a different tab just to help keep your data organized. And again, if there's one group that's in particularly important, try to create a binary variable for it. Now, I often will do that on the back end. So if you guys send me data and you have race, and it's white, black, Hispanic, Asian, other, 1, 2, 3, 4, 5, I often will then create, white. So I can compare white to not white, black to not black, Hispanic to not Hispanic. Because if you have, sometimes if you say, okay, severe OSA by race, the p-value will be significant. So we know that one of those values is the difference maker. But if you have them all together, sometimes it can be hard to tell, well, which one is the difference maker. So I usually will analyze each row by itself. So I'll say white versus not white, black versus not black, Hispanic versus not Hispanic, etc. And then I can figure out exactly which p-value is significant, and then I can focus in on that group. If you're going to do really complex stuff, talk to a statistician first. Because like you said, if you don't code that data right on the front end, you spend all this time on the back end trying to fix it. So it's better to talk to them ahead of time to get the data correct, the format correct. And so things like audiometric data, so basically anything that's longitudinal, where you have repeated measures, like that data can be very hard to analyze if it's not formatted correctly. So those are ones where you think about talking to a statistician first. And remember, REDCap can do that for you, but it still takes some understanding of what you're actually trying to do. And again, it can be very difficult to change things on the back end. And so the difference between long data and long format and wide format, and why that's important. So when you ever, like an Excel spreadsheet, each observation, sometimes it's on a single row. But if that patient has multiple observations, like weight, so you weighed them 5 times, so you have, I know Dr. Day's on the phone, he deals with cancer patients. So he's doing a quality of life survey in his cancer patients before surgery, 30 days, 90 days, 60 days, 90 days, 120 days after the procedure. And they're trying to see if the quality of life is better with one technique versus another, or one intervention versus another. So he's going to have multiple surveys. Well, typically then each survey is going to be on a separate row, but you can't really analyze it that way. You want to analyze it differently. You want to be able to track the outcomes over time. And so that's where you get into this long format. So you want each observation on the same row. So each patient should just have one row. And so therefore something like whatever, let's say physical functioning 1. That's a question on, say, the short form quality of life survey. So he's going to have 4 values for that. So how do you label it? If it's only physical functioning 1, then the software is going to have a hard time analyzing. So you got to go like physical form, or physical functioning 1-1, physical, and then, see what I mean? So you got to learn how to, you really got to talk to a statistician to get the data right, and also just the labeling right. But once you do that, then it becomes very easy to analyze data. And you can do longitudinal analysis, and we do that quite a bit. And so, in fact, one of the studies I'm working on with, actually I worked on it with Alex, and we finally got it published, was the weight gain velocity. We basically use a longitudinal type analysis. All right, so basic statistics. We'll go in much more detail about this in future lecture, but essentially it describes your data. So counts, averages, ranges, continuous data. Almost everybody uses mean and standard deviation for normal distributions. Technically, you're supposed to use median and interquartile range for skewed data, but I can tell you a lot of journals, for certain variables like the apnea-hypopnea index, you'll get pushback. No, we want the means. We don't want the median for AHI. But clearly it's not normally distributed. So, you know, do what you think is best. And then if the reviewers say you need to change it, then say, thank you very much. I'm happy to change it. Standard errors and 95% confidence intervals really shouldn't be used in basic statistics or descriptive statistics unless you're describing an entire population. So if you have a survey and you're trying to say, well, based on our survey, we think the 95% confidence interval for the population is this, then you give a standard error. But generally speaking, if it's just a study done at our institution where you have 200 patients, it should either be mean or medians with interquartile range. Proportional data always counts with percentages. Again, you can use standard error and 95% confidence interval if it's a population estimate. So you're thinking, I want to try to say what the entire population in Dallas looks like based on this sample that I took. Again, this is what I kind of mentioned. I think a lot of reviewers will want the means for some reason. Occasionally you'll get people say median, but it's just some data, they just want the mean. So I think you do what the textbook says you do, and if the reviewers ask for something else, then you give them something else. The AMA manual style is online. It's in our library. You can search it. If you have any questions about usage, about statistical tests and how to properly present them, how to reference an article or personal communication, just use the AMA manual style and you can't go wrong. A reviewer may come back and say, well, I think you should do it this way, but you can always just say, well, look, I used the AMA manual style. I'm happy to use your approach if you want. But once you kind of throw that out there, then people are like, oh, okay, I understand. It's all good. And it actually gives just really good advice on things like what words are appropriate and what words aren't appropriate. And so I actually use it quite a bit because I have to review a lot of articles for the journals. So hypothesis testing is, you know, again, you have an hypothesis. Originally we said we were going to test whether or not kids with severe sleep apnea have increased respiratory events. So now what tests do we perform in order to see if that's true? Again, the way I think of it is it's kind of like these 2x2 tables. That's where a lot of hypothesis testing comes from. And so in this one, you know, you can see it says post-op events, no and yes, and then age less than 3. So, okay, amongst these group of patients who had post-op events, who did and did not have post-op events, who are less than 3 or older than 3, is there a difference between the two? Down here is the p-value. So yeah, clearly there's a p-value. The p-value is based on this statistic here, this number, this 13. And so almost all p-values, not almost, all p-values are based on a number. And that number can be the chi-square statistics, the Fisher exact test, the t-test, the z-score. There's all kind of these little distributions that they look at to create a number. And then that number, technically they used to go to like this old book, you know, you would open up a periodic book, or I guess not a periodic book, they would open up a book, and in the appendix there would be tables for p-values, and you would find your Pearson chi-squared number, and then you'd go and find what the p-value represents. Of course, now it's done all automatically. But for this number, the p-value is, you know, pretty low. So again, this just says that, and then you can look at the numbers and kind of figure out what it means. So out of kids who are less than 2, it looks like 11% had an event, but kids less than 3, 22% had an event. It's almost double. So that's where the money is. And then you can do other tests as well, ANOVA, student t-test, regression analysis. These are more, I look at least the ANOVA and student t-test, look at it more for continuous variables in terms of analyzing continuous data. So like weight, age, AHI, you know, basically a number that goes up sequentially. The ANOVA I tend to use to analyze a continuous number by a categorical variable. So if I want to look at the mean AHI by weight classification, you know, I'll just use ANOVA as a baseline test. And then The student t-test, you can do the same thing, but it assumes a normal distribution, which we don't have as much of in our studies. But a student t-test can also be used, even if it's not normally distributed under certain circumstances. And then regression analysis is a little bit more flexible, but then you're really looking at, well, what is the effect of one variable on another? Sort of the dependent variable versus the independent variable. And ANOVA and regression, there's a lot of overlap between the two, especially the p-values tend to be pretty close. I just tend to, again, I use ANOVA for just baseline tables. So if I just have my baseline demographics, if it's a continuous variable between two groups, I almost always try to get our studies down to 1 or 2 groups, maybe 3 groups, and then say, okay, we have 3 groups that we're interested in. Is there a difference in age? I'll use ANOVA. And then if it's a categorical variable, I'll use chi-square statistics. But when I want to try to get at predicting, then I start getting into regression analysis, because then I'm interested in, is the independent variable and the dependent variable, what is the relationship between the two, and how can I control for the two? And so I use regression a lot. I think it's a great tool, and it's fairly simple to use, and it's fairly simple to explain in your papers. And you don't have to do anything super complex. You can just do a simple regression analysis, and that can be enough to show a very powerful relationship. So these are just some simple models. Again, for this, you're just looking at, okay, if you have an obese child, I called it obese 3, because I had 3 different categories for weight. And we looked at the AHI. So this basically says that the group of patients that we have looks like 163 patients. The average, or the slope coefficient, was 8.1 or 8.2. So obese kids were 11, almost 12 points higher than the rest of the group. And then you can then predict it. And so we can say, okay, well, what is the predicted mean value for the entire population? And it was 16.4. And then you can take it even further. So I can say, okay, well, what's the predicted AHI at different weights? So we went from 60 kilograms all the way up to 200 kilograms. And then now it'll say, okay, based on the data, this is the predicted AHI for each patient. And it will even give me a p-value to kind of say, well, how likely is this, like, does the data actually match? Because sometimes you get a p-value that doesn't match, and it'll say, okay, your data is too small to predict at the levels that you're predicting at. But in this case, you can see if you weigh 200 kilograms, your AHI is likely to be around 50. And then you can, create nice graphs with regression models. So I tend to, that's another reason why I enjoy it. And then it's just very flexible. You can do simple, you can do different types of models. Like this one kind of shows, if you just did a simple model of age by income, so this over here is income. If you just did a simple model, it would just be a straight line. But we know that's not the true relationship between income and age. Your income goes up, and at some point it starts to plateau, and then it starts to go down because you stop working and you start to spend income as opposed to make income. And then you can get all kind of interactions and add different vessels and or different variables to your model. And so again, that's why I prefer regression for more complex data analysis. And then you could do nonlinear models too. So you don't have to just use a number, a continuous variable. You can use a categorical variable like sleep apnea. So this one says that the probability of severe sleep apnea goes up as a child ages. And at least in this population. And then moderate, mild goes down, and normal also goes down, although the slope is not as steep. And there's all kind of models that you can use. Again, for what we do, we tend to just use linear or logistic. We don't tend to get into all these other fancy models, with the exception of hazard models for for time to event. And we'll have a lecture on that as well. So structured abstracts, you need to know if you're going to write an abstract, always go to the journal when you start writing your paper and see what the instructions to author says. First, you should try to think about what journal you're going to publish, you're going to submit your paper to as you're writing it, and maybe even before you start. But once you decide upon a journal, always go to the instruction offers to authors and see how they want their structured abstracts. This is the most common. And you don't have to get fancy, just do what they tell you to do. Most people say write the abstract after you write the paper, but as you know, we do the opposite quite a bit too. The STROBE guidelines, it's just a checklist. Let's see if it works. I'm always afraid to push these buttons and make your computer crash, huh? And I think I have to share a slightly different screen. All right, so you should be seeing the STROBE statement. And they just basically have all these checklists. And the idea is to try to help you write a better paper. Now, you don't have to include everything in the checklist, but the idea is that you go through and you say, okay, for the background, for my introduction, did you explain the scientific background and rationale for the investigation being reported? I can tell you, I review papers every day and they didn't do this. Like there's no, or the background and rationale, the background for the study doesn't match what they're trying to do. And like, okay, you spent a whole introduction talking about, you know, tonsillectomy, but you're looking at something totally different. And then what were your objectives? So if you just go through this, and then the study design, people often won't tell you what their study design is. They won't do things like date of exposure. I mean, I'm surprised at how often all of these things are missing from papers. I mean, just something as simple as, I think it says here, you're supposed to tell you what software you used. There's plenty of studies I see where they never mention what software they use for the paper. And, you know, I think the discussion part is also very good because when it tells you what you should summarize, don't forget limitations, try to provide some interpretation and generalization for your work. So people can know, what does your data mean? If you use the STROBE guideline consistently, your papers will be much better. All right, we should be back on the PowerPoint. Here's some other resources. How to write a lot. Now, I think this is more for not so much residents, but faculty. Residents, I think you guys can use this information too, but your plates are pretty full. So you're not going to be spending a lot of time writing. If you can contribute at least one paper, I think during your time here, that's a good mark. You know, you should be able to present at least one conference and get one paper published. I think that's a good baseline. If you do more than that, great. If you're going to try to do more than that, then you're going to have to branch out and work with more people. You can't just work with one person or try to do one paper at a time. You probably need to get 3 or 4 papers going at once, and you kind of do a little bit of everything as it goes. But this book by Dr. Shiva is very good, How to Write a Lot. And I think the key take home from his book is that you have to have a schedule. If you don't have a schedule for writing, you're not going to be able to write a lot. So you got to pick a day, and that's the day you write. So if you're going to present a paper at COSM next year, and it got accepted in January or November, and you know that paper is going to be due in March, then you have to say, okay, Saturday morning from 8 to 12, that's when I'm going to write. I'm not going to do anything else. So I try to have writing days. They're usually conference days. I'll do it in the afternoon, but I also have other academic days, and I just write. I close my door, do not disturb, write. Stephen King's book on writing is also very good. And he just talks about how he learned how to write and the whole process of writing. The book, How to Report Statistics in Medicine, is just a good, on how to, basically it says what it does. If you want to write up your statistical approach to your paper, if you open that book and you just go through each point and you address it, then the reviewers they may say you put too much, but no one's going to say you didn't put enough. All right, so you know, research is a flat circle. You kind of go from this project conception to analysis, write-up, poster presentation, submit to journals, acceptance, rejections, and it just kind of keeps going and keeps going and keeps going. I try to build my projects around deadlines. So syntax tends to be early summer. I think it's June. I think it already passed, but they may have pushed it out because of COVID. Triological sections meeting is generally August 1st. Combined Otolaryngology Society meetings usually starts around October 1st. Academies around February. ASCO summer meetings in March. American College of Surgeons, if you're interested in that, it's usually March, April. So I usually try to build all my projects around those meetings because that way I can at least get a poster or a presentation, even if the paper never really makes it through the revision process. This is going to change a little bit, right? Because probably a lot of the posters and oral talks are going to be virtual. So, but you still got to do some preparation. If you get a poster, usually like no talks, so you don't have to get in front of people and say anything. But the disadvantage is you don't get any face time. And face time is important, especially if you're interested in academics and advancing your career in that way. You need that face time. You need people to see you and know who you are and kind of appreciate what you do and the work that you do. The podium stuff is you get to get on stage and you get to, you know, show the world who you are and do an excellent job. But it is more work because you usually have to write a paper and you have to get ready to give a talk. And it can be somewhat more anxious, especially some meetings. Again, it won't be like this forever. For at least right now, you go in a room and it's like every head and neck surgeon in the country is in that room staring at you. And they know their stuff, and you're just kind of like, okay, do I know my stuff? And they usually won't mess with you, but you know, it only takes one person. So here are my take homes. You always start with the beginning in mind. I really recommend you start using REDCap. It's easy, secure, but again, think about how you're going to analyze your data on the back end. Think about using the STROBE statement. Even if you don't refer to it in the paper, look at it, ask yourself, are you addressing all the points that need to get addressed? And again, this has also changed a little bit. We used to say that research doesn't guarantee publications, but it guarantees trips and no call. But again, we will have conferences again. And it's nice to get away. When I was a resident, that was one of the main things we all wanted to do, is just be able to go to COSM or Academy so we can get away for a few days, because you know, you get the fellowship with people you haven't seen in a while. Usually somebody takes you out to a nice restaurant, and those days will return. All right, guys, questions?
Dr. Johnson,
Yeah.
I actually have one more comment about REDCap, if it's okay. I just like a common pitfall I think that I've seen.
Yeah.